All right, if you have not turned in your bell work page yet, just make sure you get it to me before you leave for the day, okay? But I do want to direct our attention as a group to page 74 in your books. We're going to talk about the problems on page 74 and hopefully get to the first problem on page 75. This whole task is called making sense of the three forms of quadratic functions. And right here they say the standard form of a quadratic function is often used when we're talking about projectile motion. Does anybody happen to know what standard form is?
Isn't it
Close. Ax squared plus bx plus c. Absolutely correct. That's really good recall. Yeah. So that's our standard form. Does anybody happen to know what one of the other forms is called?
There's standard, what's the one we just worked with? That's linear? No, that's y(x) equals mx plus b.
That's slope-intercept form. That's for linears. So I want to know for quadratic functions, so specifically when we're talking about parabolas. I have standard form. I love what you guys are remembering, though. Close. That's a different type of function. We're actually going to study exponentials after this unit. Vertex form. We have vertex form. Vertex form is our AHK form. Do you guys remember in Algebra 2 how you had to do graphing all the time with A, H, and K?
Yes.
This is the form that tells us about transformations. Oh, thank you. This is our AHK form. Thank you, sir. Just make sure you get that bell work turned in to me before you leave, but we've gone ahead and moved on to the next piece. So y equals A times x minus h. Those parentheses get squared. And then plus k. That's our vertex form. I'm going to scoot that over just a little bit. I do not expect you guys to memorize all the different forms. I will give you the different forms on the test. But we do need to know what they mean, when to use them, and why would I choose one versus another one, based on either what I'm looking for or what I have to work with. The other form, the third form for a quadratic, you guys have probably heard it referred to as factored form. This curriculum refers to it sometimes as intercept form, because it tells us where our x-intercepts are. But to get it into this form, we use factoring. Do you guys remember factoring with the x and the area model, the box? Does that ring a bell at all? Okay. Intercept form, you're going to have y equals a times x minus r1 times x minus r2. And R1 and R2 are just the two different roots, the two different x-intercepts. All right. We're going to focus on standard form for right now. For this particular situation that we're talking about, we're using this version of standard form. Thank you, ma'am. What does the H and then with the T inside parentheses mean? H with the little 0 is our initial height, yes. The h on the other side with the t inside parentheses means our height at whatever time they give us. Because when something is falling, whenever gravity is affecting things, where it is off the ground depends on how long it's been falling, right? So that's what that h with the t inside parentheses means. Equals -1/2, and then what does the g mean? Gravity. Times t squared, so times our time squared, plus v with the little 0 next to it. What does that mean? V naught. What does it represent in our problem? Yes, specifically the initial or the starting velocity. That's why it has that little 0 there. That little 0 is telling us what time it has that velocity. We take our initial velocity, we multiply it by the time, and then what does the h with the little 0 mean? The initial height, yes. And we have gravitational constants. We talked about those last week. 9.8 meters per second squared if we're talking about metric units. 32 feet per second squared if we're talking about imperial units. Here's where you guys have to fix something in your book. It gives you the simplified forms. I have them up on my screen. What's up on my screen is correct. One of the ones in your book is wrong. Which one is wrong in your book?
The 9.8.
Yeah. Your book has -9.8 right here, and it should be half of that. They forgot to multiply it by a half. So please fix this in your book. Okay, let's start looking at this first question here. A piece of paper and a hammer are dropped off the top of the school, which is 90 feet high. They're both dropped from a still position, so they're just being let go of. They're not being thrown down, they're not being thrown up. If we ignore air resistance, do you guys know what air resistance is?
Is that like when you tilt the paper and it goes like that?
That's exactly what that is. If I take a flat piece of paper and it's going to basically catch wind on the way down, that affects the way it falls. If I have a ball of paper, does it do the same thing?
No, ma'am.
Ball of paper is going to do what?
It goes straight down.
But it still weighs the same as a regular piece of paper, right?
But it's not, like, it doesn't catch up in the shape of the paper.
Exactly. So we're not catching any air. So we're going to ignore air resistance. So I've got a little ball of paper here to demonstrate that. I want to know, between my piece of paper and my hammer, I have the coolest little awl tool that is a hammer.
Whoa, that's cool.
I remembered that I had it third period today, and I was like, ooh, perfect. Which one's going to hit the ground first?
The hammer, because it's heavier. Let's do this quick. I couldn't see. Oh, really?
Come over and watch if you want to. Ball of paper, hammer. Yeah, I only let the one go. Whether I'm standing on top of the school or just right here,
All the same time.
they hit at the exact same time. Do these two things weigh the same?
No.
No. I actually wasn't able to demonstrate by dropping it earlier because I forgot I had something soft. This is actually pretty darn heavy. That's got a lot of weight to it. The hammer's a lot heavier than my piece of paper. Why did they hit at the same time? They're dropping from the same height. Dropping at the same time. Talk to me about velocity. Does anybody else want to feel how heavy the hammer is? It's a pretty decent weight to it, right? We would expect the heavier thing to fall faster. Why doesn't it?
I don't know.
What's acting on it?
The gravity.
Gravity. Anything else?
Oh, God.
Right.
Oh, what? So there's a knife and what else is there?
It's not pliers.
Can I take a picture of it?
Yeah. This thing is
I
really
want to
cool.
get this for my dad.
Think about these equations that we have for free fall. What was the initial velocity that I put behind the piece of paper?
None. You just
None.
dropped it.
I just dropped it. So what was acting on the piece of paper?
Nothing.
Something was acting on it.
Gravity.
Gravity. What was acting on the hammer?
Gravity.
Gravity. Same exact force is acting on both of these. I added no additional force to either one. Do either of these equations take the weight of the object into account?
No.
Because it doesn't matter. It does not matter which thing weighs more. The mass does not play a part in this. I want to write the equations for both of these. So in your books, number 1, I've got the paper here. And we're going to write one for the hammer. And I do want to make sure that we can write these equations because you guys are going to do the next one on your own, like with a partner. But I'm going to model this one, how we're thinking through it. Which one of these equations would I want to be focused on in this particular scenario? Feet. So I want this one right here, right? So for the paper, the height at any given time, so h of t, is equal to, how's this going to start? -16. What else? T squared, because I'm doing it for any time, plus what? What'd you say?
Velocity not or
Yep. What was the initial velocity that I gave the hammer? Or sorry, the paper?
Nothing.
Nothing. So 0t. We're assuming we're dropping this off the top of the school.
That's 90 feet. Or
90 feet. So plus 90. Can I simplify this at all? What would it look like cleaned up? So what about with the hammer? It's the exact same thing. We still have gravity acting on it. -16t squared. I didn't put any force behind it, so its initial velocity was 0. And the height is 90, so it cleans up exactly the same way. Since the same equation describes both of these objects falling,
you can set them equal to each other.
I could set them equal to each other. I could also use the exact same graph to represent both of them, right? So I'm going to go ahead and do that. We're going to use some graphing software as we do this. I'm not going to make you guys graph stuff like this by hand, but I want to make sure that when we look at a graph, it makes sense to us, that we know how to read it and how to make sense of it. I really like the Desmos app. Oh, wrong button. Come on. So when you go into Desmos, they have an app on the phone, or you can just go to desmos.com. Have you guys ever used this as a calculator?
Yeah.
Yeah, if you type in here, it'll just do basic arithmetic, like 5 plus 7, 12, yay. It'll plot points for me. If I use the parentheses, it'll plot my point. I can even tell it to label my point for me, and then it puts that ordered pair there for me. Or I can use it to graph. I'm going to use it to graph this. Now the only thing is, what are the axes? Y and X. So I'm going to have to use X and Y if I want it to know that I want it to make a graph. Our equation had H and T. Which one of those should I replace with the X? T. Because remember, I had H with the T equals. So that's like saying y equals, and then we had what? Negative 16, and we're going to do x squared plus 90. That graph is really hard to read. We can zoom in and zoom out. So I can zoom out, but that makes it really, really skinny. I can still click up here and it'll tell me that ordered pair. Do you guys see these two gray dots down here? I can click on those and it'll give me those ordered pairs, but it's still really hard to see on. Over here, do you guys see this wrench?
Yes.
I'm going to click on the wrench, and that lets me change what my x-axis and y-axis are. I know I want it about that tall, so I'm going to leave the y-axis alone, but it'd be really nice if I could spread it out. So instead of the x-axis being negative 99, I'm going to change that to like negative 10. And for the positive side, I'm going to change that to like positive 10. Is that easier to look at? I still have the same ordered pair up at the top. I still have these two same ordered pairs. What does this thing represent? I have this graph, great, but what does it mean? Shows, yes, this is modeling my freefall. What is the y-axis representing here?
Okay.
Height. What's the x-axis representing for me? What'd you say, Nasita? What did we replace with an x here?
H.
T, that was our time. So down here is time. Thank you, Dwayne Sola. So what are these ordered pairs representing? Height and time. What does the 0 mean here?
Height. No, the time.
Yep.
Time.
Here's my time. So that would be at the beginning, right? What's the 90 represent? The height. So what about this ordered pair? Time and height. So what does this ordered pair right here tell me?
2.372 the item is registered now.
Yes. And because we're talking about feet per second, because we used the one with the negative 16, that'd be 2.37 seconds it hits the ground. What part of this graph doesn't make sense when I'm talking about dropping the hammer or dropping the paper?
The negative side,
The negative side, why not?
because you can have negative time.
Can't have negative time. So in this particular example, none of this makes sense as our model. The model is correct, but we have to think about, okay, what actually makes sense within this real world time constraint. Does that make sense?
Yes, ma'am.
All right. So what are we going to answer as far as which one hits the ground first?
They will both hit the same time.
They both hit at the same time.
Because there's nothing changed in both equations.
Exactly. The equations are exactly the same. Same gravity is affecting both. Same velocity is affecting both. Nothing. Same initial height is affecting both. So they're going to hit the ground at the exact same time. I want you guys to look at the second one. Look at number 2. A potato is fired from a spud gun at a height of 3 meters and an initial velocity of 25 meters per second. I want you to start off by writing the equation for our potato projectile. And then I want you to use some graphing software, type in your equation, and figure out the maximum height this potato reaches and when it reaches that maximum height. I'm going to give you guys about 3-4 minutes to do this. You're welcome to work with a partner if you want to. So you need to write the equation, and then you need to model it using graphing software. You good? What this means is that the equation you're going to make it right.
I was trying to do this.
That's exactly, yes, that's like y, just right there.
Oh, yeah, that was supposed to be 2021. Wow, I can't believe I missed it.
So look at which one of these you want to use. Yeah, you're going to just leave T as T. You're going to graph it.
Because we had Emo and I at church so much.
Yeah, so remember to fix that in your book.
No, you're waiting for
Because
that
your book
one.
wrote it.
Oh, I was. My little sick. I would have been for 29. For 2020.
I want you guys to write your equation and then hop into that Desmos app or hop into Desmos on the browser. You're welcome to use your phone or your computer.
Yeah. Oh, God.
But I want you guys to model this flight.
Somebody thought I was a guy. They really thought I was a guy.
What'd you say, dear?
What legs are that?
Okay.
Wait, H is height?
H is height.
But the last one we did know height.
We knew the height.
The height was HT, what is that?
H of t is the same thing as y. That's your function notation.
Oh, okay.
All that's doing is telling you that this equation tells you the height at any given time.
Oh, okay.
That's what the h of t means. You don't need to substitute anything in there.
I just wanna wait. These need to be switched, don't they?
Mm-hmm.
T is coming. We don't know. So it's just T.
Yep. If there's something that we don't know, then absolutely just leave it as the variable that represents that.
So we gotta we like plug the equation.
Mm-hmm. You got to pick which of those you're going to use.
So,
What is the grade book going in?
My goal is to update Skyward today
Today?
with because I'm trying to get everything that was turned in late and all that stuff.
How about the homework? Because I ain't finished it.
Yeah, all that stuff is going to get put in tonight. But that doesn't mean that you can't still go and do it. Yeah.
I'm assuming that
Depending on if we're using meters or feet, you'll pick either one of those numbers, which is why
this is 25 meters per second.
And the second one is initial velocity, which would be like how much force you put in.
Are you getting the YSL? She's just saying YSL.
Am I what?
No, sorry, I was asking her. 'Cause- sorry about my mess, but I'm sorry.
You're fine.
This one is, it keeps hurting my ears. 'Cause it's too, my
Totally
ears are
understand, and we
sensitive.
don't technically have to wear them anymore.
I know,
So.
but
I know, like everybody's still wearing them, including me, because I'm like, I'm kind of used to it now. And I've gotten sick a whole lot less.
Yeah. So this is a T again, velocity. So you can combine those or no, because we don't know the time. But
We
for this
cannot
one,
combine them because one is t squared and the other one is t.
How do we do that one? Oh,
Yep, the initial velocity there was 0.
so we have to solve this or just?
Nope, I want you to graph it now.
We don't have
So I want you to open up Desmos.
Oh, on our telephone.
Mm-hmm.
Miss Eva, can I see your hammer? Yep. So these are really pretty.
Yes, ma'am.
What did you do on Friday? Where did you get these?
I got about 5 of those.
No way. Do they
Let me
work
look real
good?
quick. Because off the top of my head, I'm like, I don't remember. But let me look in Canvas. Yes, Kevin.
It would be 3t plus 25 or 35.
So what comes next in the formula?
Velocity.
Velocity. Which piece is telling you the velocity? There you go. Now there's one thing that you're missing right out in front. What do you need to remember out in front?
This part. Right.
Oh, you need that, yes. But what's in front of both of these after the equal sign?
Negative.
Yes. Otherwise, you've got it like shooting off into space. Mm-hmm.
Is this supposed to look like this?
Mm-hmm. So you'll want to zoom out, or you can hit that wrench up at the top. Yep, and then you can change your x-axis and y-axis there so that you can see it all. All right. Which one of these, for meters or for feet, would we want to use to substitute in? Meters, why? Yeah, it says 3 meters is my height, and what's the velocity?
25 meters.
25 meters per second.
Oh my God.
All right, so we're going to substitute in now. H of t. Again, this is exactly the same thing as y equals. So we're not actually substituting things in there for the h or for the t. What comes after the equal sign?
Negative 4.9 t squared.
Negative 4.9 t squared.
Plus 25 t.
Plus 25t, because 25 is what?
Initial velocity.
Yeah, that's my initial velocity. And then what do I need at the end? Plus 3, because 3 is what?
Initial height.
The initial height. So this is what you're going to graph. You're going to have to change what it's showing you on the x-axis and the y-axis. Because when you first put this into Desmos, it goes from like negative 10 to positive 10 on the x-axis and from like negative 5 to positive 5 on the y-axis. And that's not going to show all of this. So you'll want to hit the wrench so that you can change what it's showing you. You want to be able to find what? What part of the graph are you most interested in?
Or like the time.
The height. When you fix your x-axis and y-axis, you should have something that looks kind of like this. All right, so I've got different colored dots up here on this graph. To answer the question of how high does the potato reach and at what time does this occur, do I want the blue dot, the purple dot, the black dot, or the green dot?
The black dot.
Why?
Because that's the highest point.
That's the highest that it ever goes. If it's the highest it ever goes, we refer to it as the maximum. What do you think we would call the lowest it ever goes? Minimum. Okay, I don't know how well you can see the numbers up on my screen, but hopefully you have it graphed on your own. So now I need to read that ordered pair so that I can actually answer this question. What is the first number telling me? Time. And the second number is telling me the height. So the max height is about how much?
34.8 repeating.
34 point, so you guys okay if we call it 34.9?
Yeah.
34.9 what? Meters. When does that happen? Yeah. At right about 2.6 seconds. Awesome. We will pick up with page 75 tomorrow, and we'll continue talking about the different forms, but we are going to practice with some graphing stuff too, so make sure you guys become familiar with that Desmos app.